This is section 6.4, day 2, part 1, simplifying square roots. There are 2 videos that will complete the back of your worksheet, so please make sure you watch part 1 of day 2 as well as part 2 of day 2.
So now we're moving into the next property that we have of square roots. We just talked about the product property of square roots, and now we're going to talk about the quotient property of square roots. You can get a hint from the title of the property, and since it starts with the word quotient, hopefully you remember we're going to be dividing somewhere in this problem, and because of the division, we're going to use the quotient product of square roots to solve. So again, this is when they're not perfect squares. I'm going to take you back just a second and go back to 6.1 when we talked about fractions under the radical signs and things that we're allowed to do. If this is an example of what we did in 6.1 notes, so if you want to look back on that, you'll see it in there. If we have the radical of, let's say, 4/25, and in 6.1 we saw that the numerator was a perfect square and the denominator was a perfect square, we were allowed to break this into the idea that you can take the square root of the numerator and the square root of the denominator. That's what this property says, and I'm going to show you a little bit more about what happens when they're not. But right now they are perfect squares in 6.1, so we just said this simplified to 2/5. And that's how we went about the process. Again, another example from 6.1 was the square root of something like 28/7. So looking at that fraction, looking in the numerator, 28 is not a perfect square. Looking in the denominator, 7 is not a perfect square. So what do? So in this case, we realized that their quotient, the square root of 4, 28 divided by 7, turned out to be a perfect square. So because of that, we simplified it, found 28/7's quotient, and then we took the square root of 4, which gave us the 2. So in 6.1, we changed fractions into perfect squares, and we solved it from there. But in 6.3, we're looking at those non-perfect squares, that the numerator and denominator are not perfect squares, and that quotient, once divided the fraction, is not going to be a perfect square. So what do we do in those cases? So we use that quotient property of square roots. So it says in words, and we'll talk about it, rewrite the radicand as the square root of the numerator divided by the square root of the denominator. And we need to remember, since we're dealing with fractions, where x is greater than or equal to 0, but y, that denominator, needs to be greater than 0. Remember, we're not dividing by 0. We can't simplify that. So we're only looking at fractions right now that have y greater than 0 in the denominator. So for number's sake, what if we looked at something like the square root of 15/64? And in this case, I can't simplify the 15 and the 64. There are no common factors between them, so they're relatively prime. However, 15 not a perfect square, but 64 is. So what does this quotient property allow me to do? It allows me to break. So I'm going to break this up into the radical of 15 divided by the radical of 64. Just like we did in 6.1, even though that 15 is not a perfect square. Now I'm going to simplify. 15, we know it's irrational because it's not perfect. And if we look at the list of perfect squares, list of its factors, there are no perfect squares. So I can't even use my product property of square roots to simplify that. So the radical of 15 is in lowest radical form. So I'm going to leave that numerator alone. In lowest radical form, that is the radical of 15. However, the denominator can be simplified, since it's a perfect square, to 8. So my simplified fraction using the quotient property is the radical of 15/64 turns out to be the radical of 15 divided by 8. So again, we can simplify. Is it going to be an integer in the end? Not in this case. There's not going to be much that's perfect. So we're going to keep it in radical form as long as it's in lowest radical form, and we've simplified this fraction using the quotient property. So we're going to do a couple more in the next video, and then you'll practice this idea as a new checkpoint. Alright, so part C, after we just went through the quotient property of square roots, we're going to actually use it again on a different example. So in this example, we have the radical of 11/16. Both terms, numerator and denominator, under that radical sign. So now it's about using that quotient property of square roots, sorry about that, and being able to simplify this. So by sight here, we just have to do a quick check. 11 is not a perfect square, and 16 is a perfect square. So I have a case here that the numerator is not what the denominator is. The quotient property of square roots allows me to separate this and say, since I'm finding the square root of a fraction, I'm allowed to find the square root of the numerator and divide it by the square root of the denominator. So I'm going to rewrite the square root 11/16 as the square root 11 divided by the square root of 16. And then I'm going to go through simplifying this. Now we just look at the numerator here. And going back to our product property of square roots, can I simplify the radical of 11 any further by pulling out its perfect square factors? And if I look at the factors of 11, the only factors of 11 is 1 and 11. And neither one of those are perfect squares. So what does that mean? That means that the radical of 11 is already in lowest radical form. We can't simplify it any further than that. So I'm going to leave my numerator alone because I've justified that it's in lowest radical form. However, looking at my denominator, and if we just look at the denominator here, that's a perfect square. So I can simplify that denominator one step further into what the square root of 16 is. So this is going to stay the radical of 11 because it's in lowest radical form, and this denominator is going to change to 4. If I have it right now as a current fraction, I can separate that coefficient, that number, from the radical. And if I have the radical of 11 divided by 4, I can rewrite this as 1/4 radical 11. Remember how we separated slope? We took, if we had 2x divided by 3, what were we allowed to do? We were allowed to rewrite that as 2/3 x. It's the same thing here. Remember, we're dealing with radicals like they're variables, and we're simplifying it just the same way. So another example that we might have is, what if we had x divided by 5? And I asked you to rewrite that so that I saw the slope, the m, times the x. So when we rewrote that, we wrote it as 1/5 x. And I used that same idea in my square roots. That if I have the radical of 11, almost like my x, divided by 4, I'm allowed to separate that fraction and write it out front, 1/4 of the radical of 11, just like we say it's 1/5 of x. So remember, our rules that we've practiced with variables are now being used for our square roots. So we're going to go through this process right at the bottom at your checkpoint, which I'm going to show you a word problem before we get there. So we'll go through the word problem in the next slide, and then you'll do your checkpoint in the end. Ask any questions. Remember, under the video description, you have your flipped feedback form. You can send me a question at any time, or send it to me through your nmrsd.org account, and we can go over the answers tomorrow.
Please make sure you watch the next video called Section 6.4, Day 2, Part 2 to be able to finish your notes that are due tomorrow.